Let us start a new chapter, linear equations in two variables. Now, equations in two variables, as the name suggests, will have two variables. But this will be a linear equation. Let us take an example. Say 2x minus 3y plus 7 equal to 0. This is a linear equation in two variables. Why two variables? We have two variables here. One is x, another is y. Why linear? Because both the cases x and y, the degree is 1. So for the equation to be linear, the degree of the variable has to be 1. Now the graphical representation of this linear equation, just like linear equation in one variable, it will be a straight line. Graphical representation of this also will be a straight line. What is the standard form of linear equations in two variables? It is ax plus by plus c equal to 0. This is the standard form of representing linear equations in two variables. If you graphically represent this line, it will be a straight line. So this line is ax plus by plus c equal to 0. Now every point on this line, suppose that this point is x1 y1, this point is say x2 y2, or any one more point here, we'll take it as x1 comma y1. Now every point on this line is a solution of this linear equation in two variables ax plus by plus c equal to 0. Now if we have two linear equations in two variables, how to represent them? This is the way. a1x plus b1y plus c1 equal to 0. This is one equation, and the another equation will be a2x plus b2y plus c2 equal to 0. This is the standard representation of two linear equations in two variables. Here x and y are the variables, and a1, a2, b1, b2, c1, c2, these are real numbers, need not be integers. It can be even irrational numbers. We can have a1 as root 2, no problem. Now if we can represent these two linear equations in a single graph, suppose let us draw here. This is x, this is y. Let us draw equation 1, that is a1x plus b1y plus c1 equal to 0. So let us draw this one. So this is the line. So this is the line L1, which represent the line a1x plus b1y plus c equal to 0. Let us take one more line. This represents the other linear equation in two variables. This line, let us say L2, and this represents a2x plus b2y b2y plus c2 equal to 0. This is c1, sorry. Now every point on this line L1, every point, take thousands or hundreds for infinite number of points on this line L1, every point is a solution of a1x plus b1y plus c1, and every point of this line is a solution for the line for the equation a2x plus b2y plus c2 equal to 0. Now these two lines meet at a point, let us say A, where the coordinates are x and y. Now this point A is on line L1, this point A is also on line L2. So that means this point A is a common solution for the line L1 and L2. So this point A, which is the intersection of lines L1 and L2, is known as the solution of linear equations in two variables. They are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So for this pair of linear equations in two variables, the point A, that is x comma y, is the solution. So if you have any two linear equations in two variables, you can plot them in the same graph, and the point of intersection of those two lines is the solution. Now, it doesn't mean that if you plot two linear equations in two variables in the same graph, always they meet. No, they may not meet. There are other scenarios too. Let us see what are they. Scenario 1. In this case, what happens is both the lines are coincident. Lines are coincident. So this is one line. The other line is also on this only. Sorry, I could not draw it properly. So this is L1 comma L2. So both the lines which are one above the other. So every point on this line is a solution of both the linear equations in two variables. Now in the second case, the lines are parallel. So if you draw two lines, so this is one line, this is another line, this is L1, this is L2. So L1 is a1x plus b1y plus c1 equal to 0. This is L2 equal to a2x plus b2y plus c2 equal to 0. These two are parallel. They are not going to meet anywhere. You are going to have a solution only if they intersect or if they are coincident. Since these lines are not going to intersect at any point, then we don't have any solution in such cases. So here, no solution. So in this case, when the lines are coincident, the solutions are infinite. That is, every point here on these lines are the solutions for both the lines. So infinite number of solutions in this case and no solution in this case. Now let us see what are we going to learn further here. So first one. Now without plotting, how to find out, without plotting, how to find out two linear equations in two variable, whether going to intersect, whether they will intersect or not. We will find out without drawing the graph. Intersect, whether they intersect, that means whether you are going to have a solution or whether they are coincident, that means infinite solution, infinite number of solutions, or whether they are parallel, that means no solution. We will find out without plotting the graph. That is the first. Second is find out the solution, find out the solution using graph. We will solve one problem like this, we will plot a graph. Then third, solving the equations, the two linear equations in two variables, solving the equations using the method substitution, that is substitution method. That is third one. Fourth one, same thing, solving the equations using elimination method. Fifth one, solving using cross multiplication. This is the third method. So we are going to learn three methods. Cross multiplication method. And the last one, now equations which are not linear, that are not linear but reducible to linear, solving such equations. What we will do is these equations are primarily not linear equations, but we can convert them into linear equations and then solve them using one of the above methods. Now, first one, that is how to find out whether two linear equations in two variables are intersecting or coincident or parallel without graph. Let us take an example. So 2x minus 3y plus 7 equal to 0. This is one linear equation in two variables. The other linear equation is 5x plus 4y plus 8 equal to 0. In this case, this is a1, this is a2, b1, and this is c1, and this is a2, this is b2, and this is c2. Now let us calculate a1 by a2. Now a1 by a2 equal to 2 by 5. b1 by b2 equal to minus 3 by 4. c1 by c2 7 by 8. Now we will first consider these two, a1 by a2 and b1 by b2. Now here a1 by a2 is not equal to b1 by b2. In two linear equations in two variables, if the ratio of the coefficients of x and ratio of the coefficients of y, or first variable and second variable, if they are not equal, then these two equations are intersecting and we will have exactly one solution. If a1 by a2 not equal to b1 by b2, the lines are intersecting and we will have exactly one solution. Let us take one more example. 2x minus 5y plus 8 equal to 0 and 6x minus 15y plus 24 equal to 0. Now a1, b1, c1, a2, b2, c2. Now let us find out a1 by a2. a1 by a2 is equal to 2 by 6 equal to 1 by 3. b1 by b2. b1 by b2 equal to minus 5 divided by minus 15 equal to 1 by 3. c1 by c2. c1 by c2 is 8 divided by 24. Here also is 1 by 3. So in this case, a1 by a2 a1 equal to b1 by b2 equal to c1 by c2. In such a case, where the ratio of the corresponding coefficients are equal, then the two equations are coincident. When equations are coincident, we'll have infinitely many solutions. Third example, x plus 2y minus 7 equal to 0, 5x plus 10y plus 2 equal to 0. Now a1 by a2 equal to 1 by 5. b1 by b2 equal to 2 by 10 equal to 1 by 5. Now c1 by c2 equal to minus 7 divided by 2. Now this is the scenario where we have a1 by a2 equal to b1 by b2 but not equal to c1 by c2. In such a case, the two linear equations are parallel and you do not have any solution. So no solution. So now if a pair of linear equations have the solution, when do they have the solution? The two linear equations have solutions when they are intersecting or coincident. When they are intersecting, you got exactly one solution. When the lines are coincident, then infinite solutions. In such cases, when you have a solution to the a pair of linear equations, then the two equations are said to be consistent. The two The pair of linear equations in two variables are consistent if they have the solution, that means either when they are intersecting or when they are coinciding. When you do not have a solution, that is no solution. When do you have a no solution? When lines are parallel. Then we call that the pair of linear equations in two variables are inconsistent. Now let us solve a problem. Solve the following system of linear equations graphically. 3x plus 2y minus 11 equal to 0 and 2x minus 3y plus 10 equal to 0. So we have to draw a graph and solve these two linear equations. Now, so this is 3x plus 2y minus 11 equal to 0. This can be represented as 2y equal to 11 minus 3x or y equal to 11 minus 3x divided by 2. When x equal to minus 1, then y equal to 14 divided by 2, 7. When x is equal to 1, then y equal to 8 divided by 2, that is 4. Then x equal to 3, then y equal to 3. So it is 2 divided by 2, this 1. Now let us take the other equation. 2x minus 3y plus 10 equal to 0. Therefore 3y equal to 2x plus 10 or y equal to 2x plus 10 divided by 3. So when x equal to minus 2, then y equal to 6 divided by 2. When x equal to 1, then y is equal to 2 plus 10, 12. So this is 12 divided by 3. So y equal to 4. When x is equal to 4, then y equal to 18 divided by 3. So y equal to 6. So these are the 3 points for the equation 1. These are the 3 points for the equation 2. So whenever you want to draw a graph, you need minimum 3 points. Actually 2 points are sufficient, but if one of them goes wrong, you won't know whether everything is wrong and right. So if you have 3 points, if those 3 points do not come in a straight line, you know that somewhere you have done a mistake. So always plot minimum 3 points for each equation. Now here I have just plotted those things here. So this is the equation minus 1, 7. So this is for the equation 3x plus 2y minus 11 equal to 0. Then the other line is this one. So this is for the equation 2x minus 3y plus 10 equal to 0. Now we have plotted these two lines, taking the 3 points for each equation. So this is the line L1, this is the line L2, and these two lines meet at a point 1, 4. So the solution here is, that is 1, 4. That is a common point where the two lines intersect, and that is the solution. And here I have also marked the area between the two lines and the x-axis. Sometimes in the exam they ask the question saying that mark the area between the two lines and x-axis, or sometimes y-axis. Sometimes you are also asked to calculate the area of between these two lines and the x-axis or y-axis.